The universe is a twilight zone of secrets, unexplained mysteries, and black holes, shaped by unseen forces. In this video, we will reveal some of them. What lies beyond the universe? It is generally considered that the universe has no bounds, no beginning, and no end. Perhaps after today, you'll no longer consider our universe synonymous with infinity. After all, what has a beginning, sooner or later, will find its end. The infinite nature of the universe suggests that it must be infinite, not only in terms of space, but also in terms of time, which means it would contain an infinite number of stars. If that were the case, our sky would be densely populated with stars and incredibly bright at all times of the day. However, the darkness of the night sky suggests that the timeline of the existing cosmos is not infinite. And so, according to this theory, the universe was created as a result of a powerful explosion from a point of densely packed matter and energy, also known as singularity. Mark a sheet of paper with a small dot, then try to crush the paper to the size of that dot. Now imagine before this Big Bang, our universe was contained in a space smaller than the dot you just drew. The amount of pressure within it was incredibly high, and it feels natural that eventually this presence would result in expansion. Just as the paper in your hands is trying to take its previous form, the universe expanded, albeit on an entirely different scale. And everything in the universe, past, present, and future, is the consequence of that event. Everything we see and feel, the matter that we're composed of, everything formed thanks to that process. So how was everything we see around us born from such a destructive process? At the beginning, in a millionth of a second, almost instantly, spread the extremely high-temperature substance, the plasma. From that emerged the elements that make up our world today, such as protons, neutrons, electrons. This process is known as baryogenesis or baryosynthesis. It led to conditions that made it possible for hydrogen and helium to form, which subsequently formed the stars. The life cycle of a star will form everything that our world is made of. First, let's talk about how we were able to have a glance all the way back to the start of the universe. And then we can discuss why it is so difficult to find its edge. To travel to the past, you'll only need a TV. And now that it's in front of you, watch. Without a signal, all we see on the screen are interference and white noise. But right now, you're watching a process that's a direct consequence of the Big Bang. Look closer. This is relic radiation of the universe, also known as cosmic microwave background, or CMB. In the 70s, the process of space exploration resulted in the discovery of a number of zones we could not see properly. Some of the images looked as if there was a lens flare. The strange thing was that all the cosmic sources of light known at the time, such as the dying or emerging stars, were too far from these flares. They couldn't have been the reason for this phenomenon. This is how the scientists learned about relic radiation, and what you're seeing on the screen is the effect of this radiation. This white noise is the real echo and voice of the early universe. When scientists set out to research this phenomenon, it became apparent that the radiation occurred at the very moment when the universe was first lit up by the emergence of chemical elements. We learned that this radiation is not related to the stars or other sources of light thanks to the WMAP probe. Thanks to WMAP, we were able to receive the first comprehensive map of relic radiation in the universe. More detail was added to the map thanks to the work of the Planck Space Observatory. Take a look at it. Doesn't it look like the previous TV image, but in color? This echo of the Big Bang is dispersed across the universe incredibly even. This is the light of the birth of our universe that's existed since the Big Bang. And thanks to this light, we're now able to see the true structure of the universe and realize the universe is finite. The things we are able to see or calculate using a computer model was called the observable universe, and the things that we can explore within it are known as the meta-galaxy. So where are we within this system? Let's have a look. There's our home planet Earth and the solar system. The solar system is a part of the local stellar system. Along with the neighboring stars and their systems, we are part of the Milky Way galaxy. The galaxy itself is part of a larger group of galaxies. As we zoom out even further, we can see our place among other galaxies in the Laniakea supercluster. Seems huge, doesn't it? The final reference for scale will be the observable universe. In the grand scheme of things, we are only a tiny grain of sand. But even an entity of this size has its limits. We're facing the fundamental question. Everything that we see, is that the extent of the universe? How can we see beyond the light emitted by stars? Take a closer look at the map of the cosmic microwave background. The brighter spots signal the changes in temperature in space, which signifies where the star systems, galaxies, and supergalaxies can be found outside of our visual range. Is it possible to use relic radiation to see the entire universe? Think about the night sky. If you're on a brightly lit street or next to another source of light, such as a campfire, it's difficult to make out the faraway stars in the sky. Same principle applies here. Relic radiation illuminates the universe in all its glory. However, its light also hides the dark alleys of the universe. For example, the areas devoid of stars. It also hides black holes and places in our universe that have not yet been reached by light. Remember, the consequences of the Big Bang are still relevant. So is there anything beyond this edge? It seems that the answer to this question was found through the inflation theory. According to this theory, the bounds of our universe continue to expand at a rapid exponential pace, which leads to a conclusion that the universe cannot have a concrete boundary. Let's circle back to that piece of paper you crumbled at the start. Has it begun to unravel yet? It's obvious that sooner or later, it will come back to being the same size as the sheet you grabbed initially. The most elementary physics dictates that the inflation theory has its issues, because the laws of physics work in the same manner in every part of our universe. Even though scientists found countless things that confirm the rapid expansion of the universe after the Big Bang, as well as plenty of facts that suggest continuing expansion, that's far from being the big picture. For example, observations showed that galaxies and stars have an ever-increasing speed as they move apart from each other. Seemingly, this would confirm the inflation theory of the universe. Nevertheless, questions remain. What was happening when the universe did not yet exist? If the universe emerged from singularity, does that mean that there was a time before this singularity existed? If the same laws of physics apply in different parts of the universe, then why is the universe so large? Where did the energy necessary to create it come from? Doubts were always present, and the more scientists learned about the structure and history of our world, the more questions remained unanswered. The Big Bang Theory and subsequently the inflation theory were not able to answer these questions. Fortunately, there was a different theory that was recently proposed, which may be able to explain to us the things we see in the universe now, as well as things that happened before and things that will likely happen in the future. The theory of the cyclic universe, also known as the oscillating model of the universe. The foundation for this view of the universe as if it were a living organism with its own cycles of existence was laid at the beginning of the 20th century. The Friedman-Robertson-Walker model suggested that since the universe has been expanding since the Big Bang, It is only logical that at some point, it compresses back into a singularity. According to this theory, the universe as we know it exists between periods of expansion and contraction. However, soon their theory was revealed to have a serious contradiction because the concept of entropy had been discovered in the 1930s, which is the process of endless dissipation of energy through space and its decay. Entropy would mean that each cycle of the universe would require more and more energy. Friedman and his colleagues could not give an answer as to where this energy comes from initially. Think about your piece of paper. After all, without the force from your hands, nothing could have happened to it. But at the beginning of the 21st century, it was brought back from the dusty shelf. Two Princeton scientists, Paul Steinhardt and Neil Turk, have come up with a completely new version of it. Their model is primarily based on string theory. It is rooted in the idea that everything material in the universe consists of tiny particles which collectively make up something roughly similar to strings. For example, the smallest particle of light is called a photon, and it manifests as rays of light made up from many of these particles moving in a certain direction. We see this movement as light. String theory suggests there could be up to 50 dimensions in which matter exists. As these three-dimensional worlds collide, they stick together, and the kinetic energy from the impact is converted into quarks, electrons, photons, and other simple elements of matter. In turn, this process generates the energy for the expansion of our universe. And so, two colliding worlds give each other energy. This event gives rise to life in one of them, but in the end, our universe has a certain limit of both expansion and life as we know it. Over time, it will return to its normal state. After all, the energy that fuels expansion will come to an end. And then the reverse process will begin: compression. This suggests that our universe really has an edge. It's just that the edge is not geographical and doesn't look like a tangible boundary. Instead, it marks the end of the cycle and the beginning of something new. The boundary begins where our universe collides with other universes in its motion, interacting and receiving the necessary impulses for its development cycle outside the three-dimensional world we are accustomed to. Who knows what are the laws of physics beyond our universe? In the meantime, the theory of the cyclic universe is waiting for its practical confirmation. The main problem for scientists now is finding evidence of the existence of extra dimensions. So far, their existence is confirmed only by theoretical calculations. The sheet of paper you crumbled earlier is a great example, because to that sheet, you are the inevitable force that changed its structure. You are the catalyst for the change. And you're the one controlling when to stop the compression process. Humanity is yet to determine what acted as the catalyst for the change of the universe and what it will lead to in the future. Whether it was an impact from a neighboring universe, the Big Bang, or something else entirely. We're very close to finding that answer. To being able to look over the edge and say, everything happened for a reason.